All right, guys, I don't know how to express to you how much, like, this is, like, the most fun part. I shouldn't say the most fun part, but it is one of the many fun parts of algebra when you get into working with how numbers work together and working with quadratics. So working with quadratics, there's this big thing about factoring. Yesterday or the day before this, on concept 1, we talked about greatest common factors. Now you're going to be doing factoring trinomials, and I call it the X method. And basically, this is a little tidbit of what each thing means. So if I give you a trinomial, like here's my puzzle time. If I give you an X, you're going to put the product of A and C, which is A and C. You're going to put that up here in this top part. We're going to multiply first term times the last term, put it here. And then at the bottom, we're going to put the B value, which is the middle. The B value goes here. And then on the two sides, you're actually looking for factors, things that you can multiply together to get the middle. So you're going to multiply them to get the middle. But we are going to add them to get the bottom. So here's like my little puzzle time. So this is a 1. 1 times 6 is 6. It's positive, correct? And my positive 5 goes in the bottom. Now with this, I'm not having you do the full factor by grouping, which we'll do later on, but I will show it to you here. I don't want to lose you with it, but I'm going to show it to you just so you know these are easy ones, which we don't have to do the full process. However, as they get more difficult, you're going to have to show the whole process. So 1 times 6 is 6. My B value is 5. I need factors of 6 that add up to 5. So this means same signs. It's positive, so it has to be same signs. And this tells what they are. Same signs, both positive. So I know this is going to be a positive something and a positive something, because when I multiply them, I have to get 6. When I add them together, I get 5. So I can go out to the side and I can say 6 or 6 and 1 or 3 and 2. So I'm going to do 3 and 2 because 3 times 2 is 6, and 3 plus 2 is 5. Now I can tell you my factoring wise, we're basically breaking it back down to binomials that we'd multiply together and do the FOIL per se. This is going to be x plus 3 and x plus 2. If I wanted to check it, I could, because I could actually take x times x and get x squared. X times 2 is 2x, 3 times x is 3x, so 2x plus 3x gave me that 5x. And then 3 times 2 is 6. So it works. Now, the other piece of this, and the longer version, really looks like, I'm going to put it in pink over here to the side. We're going to put a line here, and I'm going to show it right through here. So really and truly, what this means is I would take 1x squared times 6, and I would get 6x squared. I would then say that this is a 5x if I put the b term down there. And then I would tell you that bring down the first term, which is x squared, or 1x squared. And then these two terms are actually 3x and 2x, so plus 3x plus 2x, and then plus 6. The a stays the same and the c stays the same, but this breaks up into 2 pieces. Then I would cut it in half and I would say, what is the greatest common factor out of this? The GCF would be it's an x, so I would divide both of these by an x, and I would have x times x plus 3, bring down a plus, and I can take out a 2, and if I take out a 2, I end up with an x plus 3, which is, by the way, the exact same thing here and here. Between these two terms, this and this, they have this quantity in common. So I can take out an x plus 3, and I'm left with an x plus 2, which is the same thing I got when I just did the quick and easy way. So not to confuse you, but if you want to pause and rewind and restart, you can hear this whole process again. I'm going to pretty much stick with the quick way right now until we get to where the leading coefficient is not 1. Okay, so as long as the leading coefficient is 1, we can do the quick way. When leading coefficient is 1, we can do it the quick way. So, quick way, I have the 1 times 8p is 8p. The b value is 11, goes in the middle. This is positive. So same signs, both positive. I know it's going to be positive and a positive. They have to add up to 11. So I'm going to say 18 breaks down to 18 and 1, 9 and 2. 9 plus 2 is 11. There we go. 9 and 2. So I know it's going to be x plus 9 and x plus 2. A quick and easy way. So just so you can like look at this if you want to ever do it on your own, because the x actually kind of helps you. If I make a big x and I were to ask you what goes in the top number, okay, well that top value is the AC value. So A times C. Just the coefficients, okay, because this format is AX squared plus BX plus C. And this bottom number is my B value. These two sides are, these two are multiply to AC, and these two numbers add to B. We add them, and here we multiply them. Alrighty, so here we go. All of these have a leading coefficient of 1. I'm actually finding factors of 12. So let's put our numbers in appropriately. We're going to put the 1 times 12 is 12, so it's positive 12. And the 7 goes, positive 7 goes down here. I want factors of 12, meaning multiplying, which add to 7. My signs tell me a lot. This means I'm going to same signs, because if it's positive here, to get that last term to be positive, I have to either multiply by a positive and a positive to get a positive, or a negative times a negative to get a positive. All right. So a negative times a negative, yes, but if I have negatives, when I add them, I'm going to be a negative number here. So it has to be positive. Same sign, and they are positive. So I'm going to have a positive something and a positive something. Again, I can do my little 12, 12 and 1, 2 and 6, 3 and 4. Boom. So 3 and 4. I'm going to say x plus 3 and x plus 4. Again, I can do FOIL to double check it to see if it works. The next one, I'm going to put my 20. So 1 times 20 is positive 20. Positive 9 goes in at the bottom. Factors of 20, so 1 and 20, 2 and 10, 3, nope, 4 and 5, 6, no, 7, no. So it goes back to the 5. All right, so I need to add up 9. So 4 plus 5 is 9. So same signs, both positive. 4 and 5, n plus 4, and n plus 5. The next one, I've got h's. I know it's going to be an h and an h. 1 times 18 is positive 18. 9 goes in the bottom and it's positive. So on factors of 18, which add to 9. So 18, I'm going to break it down to 1 and 18, 2 and 9, 3 and 6. Here they go. They add up to 9. So positive 3 and a positive 6. The better you know your multiplication tables, the way easier this is. And the reason that we do this, just so you have an idea, is pretty soon we're going to start putting in equal signs. And as we have it equal to things, we're going to be able to draw graphs. So just a little quick side note. What's going to happen is we're going to have a graph, and all of these are positive, which means it would be opening like a happy face. What's going to happen is when we solve them, we're going to find out where those solutions are. If it crosses the x-axis 2 times, we can actually find the values of those solutions, okay, where it's going to hit the x-axis or the ground per se. So if this was our pond, we'd like know where the edges are. Okay, contact lenses, they actually make them a certain dimension for your face or for your eyeball, etc. Things we have to do that are more than just two-dimensional, but actually functional in life. All right, so the next piece. This is a little cheat sheet. On yours, I think I already have this fixed, but let me fix it here. This is supposed to be a minus. There you go. All right, so first of all, with our little diamond here, we actually have the C is positive, the BX is positive. So notice that this is positive, right? All right, so if this is positive and this is positive, in both of my parentheses, it is going to be positive because it means same signs, both positive. However, this next one, this says same sign, but this says both are going to be negative. Both of them are negative. So let's look at that because that's a little bit different than what we've been doing so far. So if I have this problem, x squared plus 3x plus 2, I know that 1 times 2 goes up here and it's positive 2. And I know that my positive 3 goes in the bottom. I know, because they're positive and this is positive, that both of these have to be positive. So now I'm going to say, and I know I've given you the answer down here, but factors of 2 that add up to 3. Which add to 3. Well, if I took out the number 2 and did 2 and 1, those are my only two numbers. So it's going to be 2 and 1. And again, I have my x plus 2 and my x plus 1. Now the next one is same sign, both negative. So again, here I have this 2 here. That's positive 2. But my 3 is a negative 3. So I mean, same signs, both negative. Still, I'm going to have them add up to negative 3. So 2, factors of 2 that add up to negative 3 are going to be negative 2 and negative 1. Because negative 2 minus 1 more gives me negative 3. And that's where I get my negative 2 and my negative 1. Now, next, I have ax squared plus bx minus c. Okay, well, that minus means different signs. One's going to be a plus and one's going to be a minus. Now, this middle thing says the biggest is this. So the biggest is positive. Because when I add them together, I need to have a positive 3 in between, in the middle. I need that positive 3. So again, 1 times 10, negative 10 is negative 10. My positive 3 goes here, and I'm looking for factors, because you get a negative, one has to be positive, one has to be negative, right? Positive, negative makes a negative. So I can go 10 and 1, and I'm looking for actually the difference. I can go 5 and 2, boom, because the difference between 5 and 2 is 3. Now I want the 5 to be positive and the 2 to be negative. So positive 5, negative 2. Positive 5 minus 2 is 3. Positive 5 times the negative 2 is negative 10, and it works. The next one, I have the negative here means different signs because of that. But this one tells me that the biggest is negative. Here the biggest is positive, here the biggest is negative. So when I still have that negative 10 and I still have that negative 3, that negative 3 says, oh yeah, my bigger one has to be negative. So now I'm still going to use these numbers, but it's going to be a negative 5 and a positive 2. So now negative 5 plus 2 is negative 3, and negative 5 times 2 is still negative 10. Still works. So negative 5 plus 2. Here we ended up with the positive 5 and the negative 2. Remember, and then we had negative 2 and negative 1. And then here, of course, we had the 2 and the 1. All right. So that gives you kind of a little sampling of what we're doing. Now we're going to go ahead and do some more practice down below. As I'm finishing up on this one, I've got this next little set. I have the minus in the back on this last one, which means different signs. Okay, so I have different signs, but they still have to add up to 3. So positive 3 goes here, negative 18 goes here. So I want factors of 18, which add to 3. And this is different signs. The biggest is positive. So 18, I'm looking for basically, they're going to add to 3, yes, but I'm looking for the difference in the numbers of 3. So 1 and 18, 2 and 9, 3 and 6, 4, no, 5, no, 6, no. Yep, 6 and 3. Okay, so 6 and 3, the difference there is 3. So now I just need to worry about my sign. I want my biggest one to be plus, so it's going to be a plus on the 6 and a minus on the 3. So it's going to be x, oops, excuse me, not x, excuse me, n plus 6 and n minus 3. The next one, different signs. The biggest one's positive. I've got a negative 8, and I have a positive 2. 8 breaks down to 8 and 1, 4 and 2. There's my difference of 2. My bigger one has to be positive, so plus 4 and minus 2. So x plus 4 and x minus 2. Okay, the next part, g's. I've got some g's, so it's g and g. Different signs. Biggest one's positive, so plus and minus. I've got negative 10 and I've got a positive 3. So 10 breaks down to 1 and 10, 2 and 5. Boom. So the difference there is 3. My biggest one has to be positive. So positive 5 and minus 2. So positive 5 minus 2. All right. So now I've kind of like going to leave you on your own a little bit. Have you guys try these without me? So pause me, try them, see if you need to write the little X off to the side or underneath it, please do. Try it on your own, see if you can actually do these. All right. So here we are with I know it's going to be like this. Okay, because I know it's going to be binomial. The reason I know it's going to be binomial is it's x squared. So you're going to have two sets of parentheses. Even in my end, I'm going to have two sets. Now, some of them start with like a 4, but I could do 2 and 2, and then I could possibly break it down more. Right now, we're just working with quadratics. So I know this is x, and x factors of 24 that add up to 10. Same signs, both positive. Now, I just said a whole lot of information. But if we break it down and we do it little by little, like we've done before, 1 times 24 is 24. Put the 10 down below. Now, same signs, both are going to be positive. So I know it's positive something and positive something. Now, we have to multiply the 24, but add the 10. So 24, 1, 24, 2, 12. They add, I'm looking at adding to 10, same sign. 3 and 8, 11. 4 and 6 is 10. Ooh, 4 and 6 is 10. So 4 and 6, 4 and 6. All right, the next one. So we're going to put my little positive 18, put my negative 11. Okay, this tells me same signs, but they're both negative. So it's negative and negative. So y minus and y minus. Now I can say 18, the difference of 11, or actually the sum of 11. So 18, that's the same sign, so they're going to add up to 11. 1 and 18, that adds up to 19. 2 and 9, that adds to 11. So 9 and 2. The last one on this row, I've got a 40. So we're going to break it down. Boom, boom. Negative 40. Got a negative 6. And again, this is 1 times negative 40, which is negative 40. All right, so now I want factors of 40, the difference, right? So basically, I'm subtracting the two numbers, but they're going to be different signs. That's how it does it. And the biggest one is negative. So negative something, positive something. If I did 40, I want the difference of 6. 40 and 1, 20 and 2, 3, no, 4 and 10. Ooh, boom shakalaka. 4 and 10. But I want the bigger one to be negative. So negative 10, positive 4. That adds up to negative 6, but it multiplies to negative 40. Perfect. So x minus 10 and x plus 4. All right, the next set. I've got m squared plus 5m minus 6. I know it's an m and an m, different signs, plus minus. Make my little x, negative 6, my positive 5. Different signs, the bigger one is positive. So they're different signs. One's a plus or one's a minus. Basically, I'm finding the difference of 5. 6 breaks down to 6 and 1. Boom, there's the difference of 5. Bigger one has to be positive. So positive 6 minus 1. And then my middle terms, my insides and my outsides, gives me that positive 5m. The next one. I've got x and x. Same signs, both negative. Negative 14. I have 49 is a perfect square, and I know that 7, so 7 and 7. 7 times 7 is 49, and negative 7 plus negative 7 is negative 14. So negative 7, negative 7. Now, this one, because remember if I have an x and an x, that's the same as x squared, right? Well, I have an x minus 7 and an x minus 7. That's the same as x minus 7 quantity squared. Okay, I can write it that way. So don't let that confuse you. The next one, I've got P and a P, 45. So I've got a positive 45 and a positive 4 factors of 45 that add up to 4. Well, I can think 9 and 5, but that doesn't add up to 4. So in this case, 45 would be 1 and 45. 4, 5, 5, and 9, 6, 7, 8, be 9 again. None of these are going to add up, because if I add these, I get 14, not 4. So this one does not work. Does not work. I'm going to actually say does not factor. Okay, when it does not factor, we're going to call it prime. So if it doesn't factor, it's prime. Kind of like the number 13. You can't break it down other than 13 and 1. It's prime. This is a prime binomial. All right, you can pause me at this point and probably get through part of your checkpoint 15. However, I do have a little bit more to go. I know this is like taking a little bit longer than what you would like because we're already at 26 minutes. But I do have a little bit more for you right through here, this little ending part. I'm going to pause this one, let you guys like finish this up. You can practice on your checkpoint 15, and then I'm going to come back to these because they do have the y-squared and such on the back end. So I'm just going to make 2 videos for you so it doesn't seem quite as long and tedious. You can pause it and then come back to it.